Distribution of. I can start, Abby. So, hi everyone, welcome back to Made Easy Academia. So, we are here to serve you just to provide a better tutorial concerning either maths or physics or chemistry. So, please don't forget to like our videos, try to subscribe, share so other two can be able to benefit from this tutorial. So, now we are still under calculus. We have talked about a lot of things in calculus. We said we have already talked about differentiation, so we are under the integrations, and we have done we said integration 2 is divided into two. We have definite and we have indefinite, the one with upper and lower limit and the one without upper and lower limit. And we have seen how we can integrate. We said in general how we normally integrate. So we are starting from integration by substitution. So now mostly in mostly textbook the normal call it use substitutions. So it depends. You can call it use substitutions. You can use, it doesn't matter that it's always going to be you can use any alphabet of your choice. It depends on how you want it to be. So I will solve many examples, and now we can make a approach of that one too as well. So for example, they said integrate x plus 5 raised to the power of 4 dx. You can see this one is under, is it definite or indefinite? Yeah, it is indefinite because it doesn't depend on anything. It has no upper limit and lower limit as well. So then the first thing to be considered, we are going to learn what we have in the bracket to be a single alphabet. Maybe you have to be using in general. Let's just call it a U substitution. So let's be using that to save our time. You can use any letter of your choice, it doesn't matter. If you use any one of them, you are still going to have the same result. So the first step, just like the way we do, the way we did, what do you call it? Function of function. You remember that under the differentiations? Yeah, it's just the same thing like here. Example, you can just say let u to be equal to what we have in the bracket. That is x plus 5. So that means if that one is u, then we are going to have integral of u raised to the power of 4 dx. Can we see that? What we do here, we only represent what we have in the bracket to be a single alphabet. So we decide to use u here. So let u equal to what we have in the bracket. Then we have integral of u raised to the power of 4, then dx. So here, u and x, and we have du dx is equal to differential of x, remember. So differential of x is nothing but 1, and differential of constant is only 0. So now, so what I'm interested in is to find dx, because what I have here is dx. So I want to find the value of dx here. So now by making this as the subject here, I can have du is equal to dx. Why do we have that? Because when we multiply by 1 dx, we are going to have dx. So now, so instead of having dx here now, I can change my dx to be u, because under the law of integration, you can only integrate with respect to what we have. You can see here now, I cannot integrate with respect to x here because what I have here is u. So now, by changing your dx to du, then I will have integral of u raised to the power of 4 du. So now let's integrate it now. If I integrate it, remember how we normally integrate, right? So that is going to be u 4 plus 1 over 4 plus 1. Then this one is going to be u raised to the power of 5 over 5. So now recall that our u is something. Our u is x plus 5. So if I substitute the value of u here, that means that we have x plus 5 raised to the power of 5 divided by 5. And I told you when we are dealing with integration, which is indefinite, we need to add arbitrary constant to that one too as well. I hope you get that one too, bro. Yeah, fine. So now let's see another example. Let's see another examples of that. So let's see another examples. They said integral of 2x plus 3 raised to the power of 8 dx. So we are still going to follow the same process, the same method, and the same approach as well. So now the first step, learn what we have in the bracket to be a single variable. So let u equal to what we have in the bracket, which is 2x plus 3. I hope you are following, right? So now the moment we present that one to be u, then we have integral over u raised to the power of 8 dx. So what is the next thing for me to find? Yeah, is to find the value of dx. So here I have u and x, then we are going to have du dx is equal to 2. Differential of 2x, of course, and we have 2. Differential of 3, that's going to be 0. So now, if I make my ds at the subject, that means that we have du is equal to 2 dx. So I want to find dx, divided by 2, divided by 2. If they cancel this, I will have dx is equal to 1 over 2 du. Can you see that? Now, fine. So now, let's now substitute back the value of what we have there. So that means here we have integral over u raised to the power of 8. So the x that we have is 1 over 2 du, right? So now if I take out this one, then I will have 1 over 2 integral of u raised to the power of 8 du. Can you see that? Now, so we know we can integrate this one now. That means that we have 1 over 2 integral of this, that we have u raised to the power of 9 over 9. I hope you remember the way you integrate this one. You know, when we have integral of u raised to the power of 8, it's nothing but u raised to the power over 8 plus 1 over 8 plus 1. I hope you get that one right. Yeah, good. So here we have 1 times 2 here. So here we have 1 over 18. So here we are going to have u raised to the power over 9. So, but our u is something. Our u is 2x plus 3 here. That means that we have 1 over 18 u. Our u is 2x plus 3. Then here we are going to have 2x plus 3 raised to the power of 8, then plus c. So it depends on the approach of the problem that we are solving. Even if it has roots, we are still going to follow the same process, the same pattern. Let's see another example, the one that comes in form of a root. Let's look at this one. The question says integral over root of, let's say, 5x plus 3 dx. We have to integrate this one too. I will still follow you the same process. So what is the first step? You know, remember, when we have u, normally when we have u is nothing but what? But half, yes. So that means I can rewrite this question as this. Integral of 5x plus 3 raised to the power of 1 over 2 ds. I hope you get where I got this one from. When we have root is nothing but half. So I try to change that one to this. So now, the next thing is, let u equal to what we have in the bracket, right? So now, let u equal to 5x plus 3. So now, if that one is u, that means here we have integral over u raised to the power of 1 over 2 dx. So here we have u and x. This one is going to be du dx is equal to differential of 5x. We know differential of 5x is nothing but what? But 5. Then differential of 3 is what? Is 0. So if I cross multiply, we have du is equal to 5 dx. So what I'm looking for is dx. Divide all through by 5. Divide all through by 5. So that means the x is equal to 1 over 5 du. I hope you are getting it right. Now, fine. So now the next thing is to substitute the value of dx that we have here. So that means that we have integral of u raised to the power of 1 over 2. So dx is this. I have 1 over 5 du. So now I can factor out this. Then I will have 1 over 5 integral of u raised to the power of 1 over 2 du. You can see the way we are doing that. It's just so simple and straightforward. So now here I can have 1 over 5. So now let's integrate. Recall, if you are integrating, we are going to add 1 to the power and divide it by the power itself. So that means here I can have u raised to the power of 1 over 2 plus 1, 1 over 2 plus 1. So here we have 1 over 5. So here I can have u raised to the power of 3 over 2, 3 over 2. So now, here I can use law of reciprocal. If I take down this, I can have 1 over 5. Then this one is going to be 2u, 3 over 2, then all over 3. So now, this times this, we are going to add this one to be 2 over 15, u raised to the power of 3 over 2. So, but recall that our u is something. Remember that our u is, what's our u? Let's check our u. Our u is 5x plus 3. So that means there, let me write it here. So that means here I can have 2 over 15. So u is 5x plus 3 raised to the power of 3 over 2. If we can even change this to root, so here I can have 2 over 15 root over 5x plus 3 all raised to the power of 3, then plus what? Plus c. I hope you get that one right. So if it's coming from over, let's see some example from here. Then we add it together with what we have mentioned, so that you can have a better. Okay, let's look at this problem. we have a question here. Let's look at this problem. So let's look at this problem. The question says that, let's look at this one. The question says integral of x 3x squared plus 2 raised to the power of 4 dx. So let's look at this problem and see how we are going to approach it, right? So let's see how we're going to approach that. So now the first step, as I told you, the first step to be considered is to let what we have in the bracket to be what? To be a single variable. So let u equal to what we have, which is a 3x squared plus 2. I hope you are following, right? So the moment that one is u, then I will have integral of x. So what we have in the bracket now is going to be u raised to the power of 4, then we have dx. You get that one, right? So fine. So now on to the next step is to differentiate and find the value of our dx. That's what we are differentiating. Just for us to find the value of our dx. So now if I go back here, what I have is u is equal to 3x squared plus 2. Just like a normal differentiations, u and x, and we have du over dx is equal to 6x. You get that one, right? So now in making your dx at the subject, because what we are interested in is to find the value of our dx. So in making our dx at the subject, if I cross multiply, that means that we have du is equal to 6x dx. So now I want to find the value of my dx, and it's divided by 6x, divided by 6x. So if this cancel this, I will have dx is equal to 1 over 6x, then du. I hope you are getting that one right. Yeah, fine. So now if I substitute the value of the x to these equations, so meaning here we have integral of x u raised to the power of 4. Now instead of writing dx, our dx is now 1 over 6x du. Can you see that? So clearly here x can cancel x. So if x cancel x, then here I can have, all we have left is 1 over 6 here. I can factor it out. So here I can have 1 over 6 integral of u raised to the power of 4 du, right? So now the next step is to integrate this one. So if I integrate that, so here we have u raised to the power of 5 over 5. So now this times this, of course, we are going to have 1 over 30. This is 1 over 30 u raised to the power of 5. But our u is something. Our u is at 3x squared plus 2. So here we are going to have 1 over 30 3x squared plus 2 raised to the power of 5, then plus what? Plus c. Can you see that? So that's another way of just how we can make use of u substitutions. So it can also come in form of definite, in which it's going to have upper limit at the same time the lower limit. So let's look at this problem and see how we are going to approach it. So let's see how we are going to approach this one. Now, let's look at this. It's a use substitution formula to evaluate integral of 1 minus 1 3x squared root over x cubed plus 1 dx. So now, let's see how we're going to approach this one too as well. It's just the same method, the same way. Now you can see the difference between the first one we solved and this one is that here we have upper and lower limit, which is a definite. So it doesn't matter. Just follow the same process and evaluate your results. So the first step, let what we have in the root, let u equal to x cubed plus 1, right? So if u is equal to x cubed plus 1, so meaning this one can become integral of, you can have integral of 1 minus 1 3x squared u raised to the power of half, then dx. Can you see that? Fine. So now, so here, if I integrate this value, u and x, I can have du dx is equal to, differential of x cubed, you are going to have 3x squared, right? Then differential of constant is always what? Always 0. So if I make my dx as the subject, that is a du is equal to 3x squared dx. So I want to make my dx as the subject, divide both sides by 3x squared, 3x squared. So if this cancel this, then we have dx is equal to 1 over 3x squared du. Can you see that? So now after doing that, then you substitute back to that equation. So here we have integral of 1 minus 1 3x squared u raised to the power of r. So dx now, this is our dx. Dx is 1 over 3x squared du. Can you see that? Then the 3x squared can cancel 3x squared. So what we have left now is an integral of 1 minus 1 u raised to the power of r du. So I can easily integrate this. So if I integrate this one, then I can have u raised to the power of 1 over 2 plus 1, 1 over 2 plus 1. So now you can see we have upper limit to be 1 and we have the lower limit to be minus 1. So the only difference between the one that we solved earlier is that in this case we have upper limit and the lower limit, but in the other one there is no upper limit and lower limit. So just that after we finish integrating the value, we make a simple substitution for the value of x. So let's continue. Let me use this side. So now, normally if I integrate that, what are we going to have? Yeah, we are going to have u 3 over 2, 3 over 2, then I will have 1 and minus 1. So now, after doing that, so what's our u? Our u is our x cubed plus 1. So that means I will have x cubed. Okay, even before that, we can move this upward. If I move that one upward, I can have this one to be 2u 3 over 2 over 3 of 1 and minus 1. So I can factor out this. If I factor out that one, I can have 2 over 3 u raised to the power of 3 over 2 of 1 and minus 1. So what is now going to be the next step? The next step is to replace our u. Our u is x cubed plus 1. So that means if I put that, I can have 2 over 3 u is x cubed plus 1. So I can have x cubed plus 1 raised to the power of 3 over 2, then 1 and minus 1. Can you see that? So now, what does that mean? It means the upper limit is 1 and the lower limit is minus 1. So just make a simple substitutions. Let's see how we're going to do that. Let's make a simple substitutions. So what I have is this 2 over 3 x cubed plus 1 3 over 2 1 then minus 1. So what is the next step now? Is to substitute for the upper limit and the lower limit. So if I do that, that means that we have 2 over 3. So upper limit is 1. That is 1 cubed plus 1. I'm putting for the upper limit 3 over 2 minus the lower limit is 6. That is minus 1 cubed plus 1 3 over 2. Recall that when we are dealing with upper limit and lower limit, we put for the upper limit, then minus what we have for the lower limit. So here I can have 2 over 3. When we have 1 cube, 1 cube is nothing but 1 times 1 times 1, and that is 1. So 1 plus 1 is 2. Then this one is nothing but 2 raised to the power of 3 over 2 minus, minus 1 cube. It's just nothing but minus 1, right? Yeah, so minus 1 plus 1, what are we going to have? And 0 raised to the power of 3 over 2, what are we going to have? Yeah, it's 0. So that means what we have left here is 0. So now what we have left now is 2 over 3, 2 raised to the power of 3 over 2. I can use indices to evaluate this, This one is nothing but 2 raised to the power of 1. If I do that, I can have 2 raised to the power of 1 times 2 raised to the power of 3 over 2 over 3. So if I find the xm of this one, xm of, what we have here is 1. That is 1 over 1 plus 3 over 2. So what we have here is 1 over 1 plus 3 over 2 over 3. So here I can have the xm of this one is 2. That is 2 times 1, 2 plus 3, then over 3. We just do the simple fraction here. The xm of 1 and 2 is 2. 2 times 1 is 2. 2 times 1 here we have 2. 2 into 2 we have 1. 1 times 3 we are going to have 3. So here I can have this one to be 2 raised to the power of 2 plus 3 we have 5 over 2, then over 3. Depending on how you want to leave your final result. So that's let's solve one more, then we move to the next agenda. Let's solve one more, then we finish this area. Let's solve one example. Let's have one more, then we move to another method. They said evaluate integral of okay. So here what we have is a 1 to 0 of x squared minus 1 over root of x cubed minus 3x dx. So these are another questions. We are asked to use substitutions. So I told you the first thing to be considered is to represent what we have in the root, or what we have that have the power to be a single variable. So here I can say, this one can just be written as integral over 1 to 0. Then we have x squared minus 1. Recall, if I have root is nothing but I can see this is x cubed minus 3x raised to the power over 1 over 2 dx. You get that one right? Yeah, fine. So what is the next step? We say let u equal to what we have in the bracket, which is x cubed minus 3x, right? So if that one is u, then here we have integral of 1 to 0 x squared minus 1 divided by u raised to the power of half. Then we have dx. So here we have u and x, then we are going to have du dx is equal to differential of this, and we have 3x squared. Differential of minus 3x, and we have minus 3. Can you see that? Differential of x cubed, we have 3x squared. Differential of minus 3x, we have minus 3. So now something is common. Can you see what do we have in common between the two? Yeah, good. So here I can have du dx is equal to 3 of x squared minus 1, because 3 is common to the both sides. So what we are interested in is to find our dx. If I make it as the subject, that means that we have dx is equal to 1 over 3 of x squared minus 1 du. I hope you get that steps. No. Normally, what we have is du dx is equal to 3 of x squared minus 1. So I want to make my dx as the subject. If I cross multiply, that's why we have du equal to 3 of x squared minus 1 dx. So making dx as the subject, if I make it as the subject of the formula, as I divide by 3 of x squared minus 1, 3 of x squared minus 1. So if this cancels this, I can have dx to be du over 3 of x squared minus 1, just like what we have earlier in this case. So now I can substitute back here. I can have integral of 1 to 0. So x squared minus 1 over u raised to the power of half. So instead of having dx, we are going to have multiply by 1 over 3 of x squared minus 1, then du. Can you see that? Yeah. What is the next step? You can see this is the same. This is 1 over 3. I can factor it out here. I can have 1 over 3 integral of 1 to 0. Then we have, what we have here is u raised to the power of 1 over u raised to the power of half. If I change that one to fractions, it's going to be minus 1 over 2 du. I hope you get that one right. Like from this law, if I have 1 over x squared indices, this is nothing but x raised to the power over minus 2. So now, let's integrate this one now. If I integrate this, so we have u raised to the power of minus 1 over 2 plus 1 minus 1 over 2 plus 1. So here, I can have this one to be 1 over 3. So this one is going to be u raised to the power of half over half. Can you see that? Just making simple integrations. So if that one go up, then I can have this one to be, this one can move up. Then I can have 1 over 3 of 2u 1 over 2. I hope you get that one right. You can apply law of reciprocal. So let's make use of this place. So now, if I factor out the 2 also, I can have 2 over 3 u raised to the power of half. And this is nothing but, so don't forget we have the upper limit and the lower limit. Don't forget that, please. We have 1, 0, 1, 0. So here, I can see this is if I factor out the 2 over 3, I can have 1, 0 here. Then even here, I can even write this as 2 over 3. You know, when we have half, it's nothing but root. It is root of u raised to the power of u. Then we have upper limit as 1, lower limit as 0. But recall that our u is something. Our u is our x cube. So if I do that, I can have this one to be 2 over 3. Then root of x cube. No, my u is x cube minus 3x. That is x cube minus 3x. Then 1 to 0. So what does that mean? I will put for the upper limit minus, I will substitute for the lower limit as well. So here we have 2 over 3. Upper limit is 1. That is 1 cube minus 3 of 1 minus the lower limit is 0. That's going to be root of 0 cube minus 3 of 0, right? So here I can have 2 over 3. 1 cube, you know, 1 cube is nothing but what? 1 minus 3, of course, we are going to have minus 2. So 0 cube, you know, 0 cube simply means 0 times 0 times 0, that is 0. Minus 3 times 0 is 0. Square root of 0 is 0. So what we have left is minus 2. So it depends on how they leave the result. I can even convert this into a complex number. You remember how we normally change the complex number? Yeah. In order the complex number, if I have root of minus 5, this is nothing but root of minus 1 times root of 5. And we know that root of minus 1 is nothing but I times root of 5. So I want to apply the same law here now. So here I can have 2 over 3. So this is I root 2. So that's all about what we have for the u substitution. So we are going to go further to trig functions. Is it not time for prayer? I'm done with this method. Break, Abby. Yeah, I've already concluded already. I've already concluded that we are going to the next functions.
Yeah.